All right, so today we're going to be looking at, again, how to find the solution to a system of two linear equations. Um, so when we talk about a solution to an equation over here, here's an example. If we have a simple equation like 2 plus x equals 4, the solution is whatever value for the variable x makes this equation true. So in this case, obviously it'd be 2. Over here in this case, a equals 9 would make this equation true. So that's the solution to our equation. But we're dealing with linear equations that have two variables and that are in the form of y equals mx plus b. And so what we're wanting to find is what numbers can we plug in for x and for y that will make both linear equations true. So let's look at a real-world example of this. I'll go ahead and read this out loud. Yesterday, two friends went into a bank to open savings accounts. Kenji started by putting $700 in his account, $700, and he will deposit an additional $10 each week. Elena made no initial deposit, but she will add $80 more each week. In a few weeks, the friends will have the same account balance. So we're trying to find that point when they have the same account balance after the same amount of time. So what I'd like for you to do first is just read through these two examples, Kenji's account and Elena's account, and mark whatever you think the important information is with a circle or an underline, and see if you can understand what the important information is in that. So I'll pause for a second for you to do that. Now we have a couple different options. We can either graph this information first, or we can write the equations for these two. I think maybe since the graph here is first in order, let's go ahead and graph. So we're going to have both Kenji's account and Elena's account represented by two different lines on this graph. So what we want to be thinking about is what's the initial amount, what's our starting point, right? Because our dollars are over here and our weeks are over here. So this is time and this is the amount of savings in dollars. What would be our beginning point for Kenji? And what would be the beginning point for Elena? And then what's going to be our constant rate of change for each of those? And that will help us fill in our graph. So go ahead and hit pause and spend a few minutes drawing both linear equations on this graph. Alright, now we should also be able to write equations from this information, from Kenji's information and Elena's. Now remember, y equals mx plus b is the form of equation we're going to use. So again, think about the important information in our word problem. Which values can we plug in for Kenji's equation and for Elena's equation? So go ahead and hit pause and finish out those two equations. Now after you have the equations finished, we want to go back and look at our graph and figure out where the point of intersection is. Where do the two lines, the two equations intersect? And to find the x-coordinate and the y-coordinate for that point of intersection. Okay, and we're going to fill that in both here and over here. It'll be the same coordinates, right? Because it's just the point where the two lines intersect. And then once we do that, we're going to plug those coordinates back into our equation for each of the two accounts, for Kenji's account and for Elena's account. So instead of y equals something x plus something, we're going to be plugging in the x and the y for the x variable here and the y variable. And then we're going to solve those equations. We're going to simplify those equations, solve them out, and see if the equation is true for both of these two equations. So if we've found the correct solution up here for our x variable and our y variable, both of these equations should come out balanced to show that they are both true. At that point, then we can answer this question down here. What is the account balance and how many weeks did it take for those two friends to have the same account balance? So now we're going to move on to the next page, the back page. And over here on the left, what we want to do is we want to test some of these points of intersection to see whether these coordinates or these coordinates, either one, provide a solution to this system of equations right here. So the way that we would test those is we simply plug those coordinates in for x and for y. So it'd be -1 and -5 we would plug into this equation. That's what we're doing here. I'm giving you space to do that. And then to also plug it into this equation down here. And then we're going to ask this question, or answer this question, is -1, -5 a solution to this given system of equations? And we're going to justify our answer in complete sentences by using our academic vocabulary. And then we'll do the same thing with these coordinates here. Are these coordinates, do they represent a solution to these two systems? So we'll plug those in and try those as well. So I'll give you a moment. Again, pause the video and go ahead and work on that. So the last problem here is shows some work that Felipe did. So Felipe looked at this problem up here, and I'll go ahead and read the problem. It says a fashion photographer needs to hire a stylist to prepare her models. Ben charges $200 for showing up, plus $60 per hour. Jeffrey charges $150 plus $70 per hour. The photographer realizes that given the expected duration of her photo shoot, either stylist would cost her the same amount. What would that cost be? Okay, so Felipe now did this work down below, and our job here is to look through Felipe's work and see whether we agree with the steps that he took or disagree. Okay, so we're going to analyze the work of Felipe and critique his solution. So maybe we agree, maybe we disagree, but we need to use academic words and cite evidence from his work as we write out our response down below here.